The Big Bang produced lots and lots of hydrogen, some helium, and a bit of lithium. As you know, there are many more elements possible. In fact, you have carbon, oxygen, nitrogen, phosphorus, potassium, sulfur, iron and even more atoms in your body. Plus lots of hydrogen, which along with oxygen makes up the water in your body. So, where did all of this stuff come from if it wasn't made by the Big Bang? That is the question we will be exploring in this part of your unit. Let's start with stars. They formed first from the stuff made by the Big Bang, the hydrogen and the helium. So, stars like our Sun are mostly hydrogen, with a lower amount of helium. But there is some of all the elements found in nature also in our star. The colorful lines in this graphic show the emission spectrum of hydrogen and helium. So, where did all of the elements found on the periodic table come from, if they were not made during the Big Bang? They are made inside of stars. The story of where elements came from starts with stars. The first stars were almost all hydrogen and helium. Astronomers are fairly certain some lithium was also made very early in the history of our universe. More lithium, as well as beryllium and boron are formed by interactions of atoms in interstellar space with cosmic rays. All of the remaining elements formed inside stars. Nucleosynthesis is the name given for the fusion processes that occur inside of stars that over time build heavier and heavier atoms. By combining atoms into larger particles, these heavier atoms are formed. This nuclear fusion is the source of the energy given off by a star. Depending on the starting mass of a star, the end result is different. The Sun is currently fusing hydrogen into helium. Once it has run out of H in the core, it will start fusing He into C in the core. H fusion continues in a shell outside the core. This is the red giant stage. There is a brief double shell fusion stage that occurs after an inert carbon core has accumulated. The Sun does not have enough mass to fuse carbon into heavier elements. Carbon will be the end of the red for our Sun. After that is over, our star will end as a white dwarf. The stages the Sun has gone through, and will go through, are shown here. Currently the Sun is a main sequence star fusing hydrogen atoms into helium in its core while keeping Earth a nice place for us to live. In around 5 billion years, it will start fusing helium into carbon. This will cause it to expand and cool, but because it will be so much larger, things will get rather toasty down here on Earth. Finally, the Sun will shed its outer layers, forming a planetary nebula with a white dwarf at its center. Stars that start life with much more mass than our Sun can continue fusing larger and larger atoms, forming oxygen and other large atomic nuclei. When a carbon atom fuses with a helium atom, it makes oxygen. One carbon atom plus 2 helium atoms gives us neon, and one carbon atom plus 3 helium atoms gives us magnesium. Because helium nuclei are the major building block of heavier atoms, elements with an even number of protons are more common than those with an odd number of protons. The most massive stars can fuse atoms all the way up to iron in their core. Once the core fills with iron, that is the end of the road for these stars. Iron atoms cannot be fused to provide any additional energy by normal stellar processes. Have you ever seen the inside of an everlasting gobstopper? The inside of a high-mass star would look something like that candy, with layers of different elements overlaying the innermost core of iron, like the layers of candy in the gobstopper. If you can't fuse iron atoms to make heavier elements, like gold and uranium, where do they come from? When an iron core has accumulated in a massive star, fusion stops and the star begins to collapse onto the core. The tremendous heat and pressure that result cause a supernova explosion. The supernova forms all the rest of the heavier elements. We would not be here if old stars had not exploded and cast their ashes out into space to form new stars and planets, like ours. The iron in your blood that helps carry oxygen to your cells came from old dead stars. This graphic nicely shows where different elements come from. Can you find gold, silver, and platinum on this list? These metals, common in jewelry, were made in supernovae. When a star explodes as a supernova, its ashes are scattered out into space to become parts of the large molecular clouds and nebulae where new stars are made from them, including our Sun, our planet, and us.